So good morning students. Today we are going to study about chapter 3 unit 3 loudness, pitch and quality of sound. So we have studied about certain characteristics of sound, like wavelength, frequency, amplitude, like wavelength, frequency, amplitude and velocity of the sound. So wavelength is the distance traveled Wavelength is the distance traveled in one oscillation. So it started from 0, then it reaches +1, then again 0, then -1, then again 0. So it started from 0 or the mean position, then it goes to positive extreme, then again mean, and through the mean it goes to negative extreme, and then it goes to the mean position. So here one oscillation is completed. So this distance, this whole distance is the wavelength. By Greek letter, we denote it by Greek letter lambda. So this whole distance is wavelength, or we also called wavelength. We also say wavelength is equal to the, for a transverse wave, we can also say wavelength is the distance between, this is a crest and this is a trough. So distance between two crests, or distance between two consecutive crest, or distance between two consecutive trough is also known as the wavelength, because this distance and this distance will be same. This is the wavelength. Then is the frequency. What is the frequency? Frequency is the number of waves. Frequency is equal to number of waves in 1 second. Number of waves in 1 second. For example, for one wave, that is for one wavelength to be completed, the wave requires, if it takes 1 second, then the frequency is 1. If it takes 0.5 seconds for one wavelength to be completed, or for one oscillation is the time period is 0.5 seconds, then in 0.5 seconds one wave is produced. In 1 second 2 waves will be produced, then frequency will be 2. And then is time period. What is time period? Time period is the time for one oscillation. Time for one oscillation. Then is the amplitude. What is the amplitude? Amplitude is the maximum displacement from the mean position. This is the mean position. So maximum displacement from mean position is the amplitude on the either side, on positive axis also and on the negative also. This is the amplitude. Now wavelength, frequency, amplitude, these are some objective properties of the, these are some physical quantities and objective properties of the sound waves. But humans have some other perceptions of the sound, means we are able to distinguish the sound produced by two different instruments. We are able to distinguish the sound produced by two different instruments, or we are able to distinguish between the sound produced by a boy or a girl. So this difference between the sounds produced by different instruments, these are characterized by certain different quantities or qualities which are known as loudness, pitch and quality of sound. So for humans, these are also three quantities. These are not the objective quantities. Objective quantities are the wavelength, frequency and amplitude are the characteristics of a wave of a sound. But for humans, loudness, pitch and quality of sound are certain subjective quantities by which we can differentiate by sound produced by the different instruments. Now we will study about these subjective quantities, and we will also study their relation with the objective quantities. So our first quantity is loudness. First is loudness. So what is loudness? Loudness tells us how loud or or feeble, how loud or feeble a sound is. How loud or feeble a sound is. That is, if the sound is very loud or it is very feeble, that quantity, that the quality which tells us is the loudness. It is a subjective quantity. It is a subjective quantity. Why it is a subjective quantity? Because the same sound may be very loud for one person and it may not be that much loud for another person. So it is a very subjective quantity. One person may say that this sound is very loud for him, other may say this is not that much loud. Therefore this depends upon the perception of the person who is hearing the sound. So this is not a definite quantity. For a quantity to be objective, it must remain same for all observers. Means, if we say about amplitude, if the amplitude of the wave is 1 centimeter, then for every person it is 1 centimeter. No person will say that it is less than 1 centimeter or it is more than. So it is an objective quantity. Similarly, the frequency is an objective quantity. If frequency is 5 hertz, it is 5 hertz for everyone. But loudness is not a subjective quantity. It not objective. It is subjective, because for one person it may be louder, for other person it may not be that much louder. So we cannot say that it is a physical quantity. It is not a physical quantity. It is a subjective quantity, but it is used by the persons who hear it to distinguish how loud or feeble the sound is. Now another is, there is now, if this is a subjective, there is a objective quantity known as intensity of sound. Intensity of sound type. What is the intensity of the sound? Intensity of the sound is, intensity is amount of energy passing through a unit area in a unit time. Amount of energy passing through a unit area in a unit time means, if the sound is propagating, if the sound energy is propagating in this direction, and we keep an area A, and this area is the, if this area is unit area or 1 meter square, this is a unit area, 1 square meter unit area, and in 1 second, the amount of energy in joules which passes through this area, which is unit area and unit time, this is known as the intensity of the sound. Intensity, this is the intensity of the sound. So it is a subjective, it is a objective quantity. So its units are, joules per second, per meter square, joules per second per square meter, and joules per second is, it is the unit of power. Watt or watt per square meter is the unit of intensity. Unit of intensity is watt per square meter, or it is, we can also call it that power. It is power per unit area. Power transferred sound energy, or sound power transferred per unit area is the intensity of the sound. And we have a relation that intensity of sound, loudness is directly proportional to the intensity. Loudness is proportional to the intensity. So it is not directly proportional, it is proportional to the log of intensity. Means if intensity increases, loudness will also increase. How it increase, that we also study. In what proportion it will increase. Next we will study about the factors on which the loudness and intensity of the sound depends. Factors on which loudness and, so there are certain factors. So before studying we can distinguish between loudness and intensity. So the difference are, loudness is subjective and it is objective. It is not a physical quantity, not a physical quantity in physics. It is a physical quantity because it can be measured. It cannot be measured. Loudness can only be perceived. We can only measure the intensity. Next, it depends upon the sensitivity of hearer, sensitivity of ears. So if a person has more sensitive ear, it may be more louder for him. But if the sound is very less, some people may be able to hear it, some may not be able to hear it. So it is it depends upon. So it does not depends on sensitivity of ears. It does not depend upon sensitivity. So it is perception. It is perceived only and it is measured. It is perceived and it can be measured. So these are the some important differences between the loudness and the intensity of the sound. Next we will study about the factors affecting the loudness and the intensity of the sound. So if something is affecting its intensity, it is naturally affecting its loudness as well. So first is we'll study about factors affecting intensity and loudness. Very first factor is the amplitude. Amplitude. So intensity is directly proportional to the square of the amplitude. Intensity is directly proportional to the square of amplitude. Similarly, loudness is also directly proportional to the square of the amplitude. Means if the amplitude of the vibrating body increases, then its loudness also increases. So for example, if we have a tuning fork, and we strike it slowly, we strike the tuning fork slowly, and here we strike slowly and we strike harder. So when we strike slowly, so it will vibrate with very less amplitude. So it will vibrate with very less amplitude. So only this much will be the displacement. So amplitude will be less. So this is the, if this is the amplitude, so it will be less. But if we strike it very harder, then the displacement will be very large. Then the displacement or the amplitude. What is amplitude? The displacement from the mean position. So amplitude will be very large. So we can show it like amplitude will be very large. So this is the difference between the amplitude. This is 0.1 centimeter and this is 2 centimeter. So amplitude increases and loudness, so here the loudness will be more. Loudness and intensity. both will be more. Both will be more. Naturally, if we are striking a surface harder, it is more louder sound is, we are hearing more louder sound, and intensity is also more, because then the amplitude will be more. Similarly, if we are striking a drum, harder the we strike, the more will be the amplitude of the membrane of the vibrating drum, and louder will be the sound, and more will be the power per unit area, power transmitted per unit area. Now there is a value, the minimum intensity which a human can hear. Minimum intensity which a human can hear is minimum intensity heard by humans. Minimum intensity heard by humans is 10 raised to power minus 2 watt per meter square. My 10 raised to power minus 2 watt per meter square. This is the minimum intensity which we can hear, and this corresponding to when this much intensity of sound is produced on dropping a pin. Dropping a pin. So when we drop a pin, this much intensity of sound, this is the minimum intensity of the sound which is produced when we drop a pin, and we say it as a 0 decibel. 0 decibel. So that what is decibel? Decibel is the unit of loudness. Decibel or sound. Decibel or sound are the units of loudness. So the sound produced on dropping a pin is we assume it to be the 0 decibel, and the corresponding intensity is the 10 raised to power minus 2 watt per square meter. This much energy, 10 raised to power minus 2 joules of energy per second is transmitted in the unit area of 1 square meter. So pin drop, we say pin drop silence, it means the sound, there should be complete silence or 0 decibel of the sound. Next is surface area, and also the minimum amplitude. Minimum here, the minimum amplitude corresponding to this is 1 into 10 raised to power minus 10 meter. This is the minimum amplitude corresponding to the minimum intensity for which we can hear the sound, the least sound which human ear can hear. Next factor which is affecting it is the surface area. Next factor is the surface area. Next is surface area. So more surface area, more will be the loudness. More the surface area, more will be the loudness. Loudness will be more. So for example, if we are striking on the board and we are striking on the pen. So on the pen has very less surface area, but board has very more. We are striking it with the same intensity. With same intensity we are striking, but the board will produce more sound than the pen, because board has more surface area than the pen, and loudness is directly proportional to the surface area. More the surface area of the vibrating body, more will be the loudness of the sound produced. Next is the third is on distance between source and receiver. Distance between source and receiver. So this is also understood, the farther we go away from the source of sound, the weaker the loudness becomes. So intensity or loudness are inversely proportional to the square of distance of source and observer. So if this is the source of the sound and here is the observer, so if the distance between them is r, then loudness or intensity inversely proportional to the both are inversely proportional to the distance between them. It means first there are two cases. So let us assume two cases. So now the sound is same. Here the amplitude is same, intensity is same intensity. This is also I1 and this is also I1. Intensity is same. So first the person is at a distance of 10 centimeter and another person is at a distance of 20 centimeter. Now the distance has been increased twice. The distance has been increased twice, then the loudness will be decreased by 4 times because it is inversely proportional square. So if for this person the loudness is 10 decibels, then for this person it will decreased by 4 times, then for this person it will be 10 by 4 decibels. If this distance is, if the distance is decreased by 2 centimeter, then it is increased by, intensity is increased by 2 square and vice versa. Then is the density, second is the density of the medium. Second is on the density of the medium. So density of medium. So loudness or intensity, loudness or intensity are directly proportional to density of the medium. So more the density of the medium means, because sound travels faster in solids than in liquid or gases, so more the density, more will be the loudness of the medium, loudness of the sound. Then on the direction of wind, dependence of loudness on direction of wind. So if the sound and wind are in same direction, then loudness increases. But if the sound wave and wind are in the opposite direction, then the loudness will decrease. This is a relation between the loudness and the now we also have one more thing, the relation between the loudness and the intensity. So loudness is proportional to log of intensity. Loudness is proportional to the log of intensity. It means if there is 1 decibel change in loudness, if the change in loudness is 1 decibel, then the corresponding change in intensity is 26% change in intensity. 26% change in intensity. So if the sound changes from 2 decibels to 4 decibels, the change in intensity will be, the changes of 2 decibels, the change in intensity will be 52%. There will be 52% change in the intensity. Also there are certain values of the decibels, certain values of the loudness. So loudness of soft whisper, if we are softly whispering, the loudness is 30 decibel. So normal conversation, it is around 50 decibels, and siren is around 120 decibels, and sound of loudness more than 120 decibel is considered as noise. It is considered as noise, and it is harmful for human ears to listening this sound for long duration. It is harmful for human ears. So this is the first subjective quantity, loudness, and intensity, which is a objective quantity. Now we will study about the next quantity, which is the pitch of the sound. So loudness tells about the how much loud or how much feeble the sound is. The sound may be from the same source or maybe from the different sources, but their loudness, we can, how loud we perceive it is the loudness. Next is the pitch. Second quantity is pitch of the sound. So what is the pitch? The characteristic of sound, characteristic of sound by which we can differentiate, between a shrill sound and by which we can differentiate between shrill sound and dull sound. By which we can differentiate between shrill sound and dull sound. Dull, or we can also say it as a grave sound. Dull or grave is the that characteristic. This is the pitch of the sound. It means, so we are suppose even if our eyes are closed and we have two persons, and simply by, even if we don't know the two persons, but simply by hearing his voice, we can tell that the person is a boy or a girl. Even if we have not heard the person before, but we can say just by hearing that the person speaking is a male or a female. Why? Because boys have a dull sound or low pitch sound, while girls have a shrill sound, shrill or high pitch. The sound of boys are dull. Similarly, one more example, sound of a drum or a tabla versus sound of a flute versus sound of flute or violin versus sound of flute. So if we hear the sound of a drum or a tabla and we hear the sound of a flute and violin, we can clearly differentiate that there is a difference. This sound is very shrill and this sound is very dull or very grave. So the quantity, the characteristic we are differentiating here is the pitch. The pitch is telling that this is a low pitch sound and this is a high pitch sound. So the pitch depends upon frequency. Pitch depends upon the frequency of the sound. Higher the frequency of the sound, more will be the pitch. So higher frequency, more will be pitch of the sound. What is the pitch of the sound? Pitch of the sound is the what is the frequency of the sound? Frequency is the number of waves produced in 1 second. So So for example, if we have two waves, if we have two waves and both are having same amplitude, both are having same, both are having same amplitude, but in 1 second, suppose only one wave is produced, but here in 1 second, so in 1 second more than one waves are produced or two waves are produced, means this have a higher frequency and this have a lower frequency. So this sound will have low pitch, and this sound will have high pitch. This will have a high pitch. So some other examples of low pitch and high pitch. High pitch, low pitch, this we can consider as a low pitch, and corresponding high pitch will be, this will be a high frequency and high pitch. This is low frequency and low pitch. So this quantity, by this quantity we are able to differentiate between two sounds which are more shrill or more dumb. There is one more example. Now suppose we are having a bucket under a tap and the bucket is getting filled by the tap. So we have realized, in day-to-day life we realize that when the bucket is about to fill, without seeing that it is filled or not, just by hearing the sound of the water coming into the bucket, we can say that it is about to get filled, just by hearing the sound. So how is it possible? So suppose there is a bucket and water is coming in the bucket. So the bucket is, when the water is just coming in the bucket, and the second case when bucket is about to get filled, when the bucket is about to get filled, there is a difference between the sound. The sound produced here is very dull, or sound produced here is of a less dull. This is less dull or more shrill, Why? Because as the water is coming into the bucket, so here, because of the pressure of the water, the air in the bucket, the air starts vibrating. Here also the air starts vibrating. This is the air column. This is known as the air column above the water surface. And because here the length of air column is more and here the length of air column is less, the frequency is inversely proportional to length of the air column. So when the length is more, the frequency is less and the sound is dull, and the bucket is about to get filled. At that time, the length of the air column is less and length is less, therefore frequency is more. So we hear a more shrill sound and we can estimate that the bucket is about to get filled. So this is the second quantity, which is known as the pitch. Now there is one more quantity by which we differentiate between the sounds which are of same amplitude and also of the same frequency. The amplitude is also same and the frequency is also same. Still, the two sounds are different. Means if someone is playing a piano and another person is playing a violin, but sound is having, both are producing the sound of the same amplitude and of the same frequency, still we are able to differentiate that this sound is coming from the piano and this sound is coming from the violin. We can still differentiate between the sound. So there is one more quality, and that third quality is the timbre or quality of sound. Quality of sound, or we also known as the or quality of sound, or this also we call it as wave form of the sound. How, what is the form of the wave which are sound? For example, certain examples are there. So first we will study with some examples. So very first is sound from a tuning fork. Second is sound from a violin, and third is sound from a piano. So sound from a tuning fork has a sinusoidal form, has a sine wave. Sine wave. This is like a sine wave. The sound of the from violin is very, it rises and it falls very sharply. It rises and very sharply it falls. If we hear a piano, the sound is rising very sharply and falling very sharply. So its waveform is like this. So this is a sawtooth waveform. Sawtooth waveform. So this wave, it looks like the tooth of a saw. So this is known as a sawtooth waveform. As a sawtooth waveform. And third is waveform from a piano. From a piano, the sound wave coming like, the wave is coming like this. This is a waveform from a piano. So these are three different waveforms. All the waves have same amplitude. Suppose all have same amplitude. Here also amplitude is A1, here also amplitude is A1, here also amplitude is A1. Frequency or pitch is also same. So this is also F1, F1, F1. Means here also two waves are formed in 1 second. Here also two waves are formed in 1 second. And here also two waves are formed in 1 second. Frequency is same, amplitude is same, pitch is same, loudness is same. Still these are two different. So these are two, we are able to recognize that this is from a tuning fork and this is from a sawtooth, and this is from a violin, and this is from a piano. So this quantity is known as the quality of sound. So by this we can differentiate. Our next is the noise. What is noise? So any unwanted sound is known as noise. Unwanted and very loud sound. Noise is also very subjective quantity. So noise is noise or noise pollution. Now we'll start about noise pollution. So what is noise pollution? What is noise pollution? So sound of loudness more than 120 decibel is noise. Sound of loudness more than 120 decibel is noise, and noise pollution is any unwanted sound. Any unwanted sound is known as the noise. So there are so many drawbacks of noise pollution. What are these? These are there are health problems. There are health problems, hearing issues, hearing issues, sleep disorders, so or even cardiac problems. So these many problems, these are the certain harmful effects of the noise pollution. So how the noise pollution can be decreased? By education. Means if somewhere there is written that this is a silent area, we should not produce noise here. So by education we know that we should not use loudspeakers at night. So by these ways we can decrease the noise pollution. So this chapter is completed. Kindly revise, and if any doubt is there, you may clarify in the class.